This is Mrs. O'Neill for AP Chemistry, Chapter 15, Section 4, Heterogeneous Equilibria. Hopefully that rings a bell. Heterogeneous means different phases. So that means the substances, reactants, products are going to be in a different phase, solid, liquid, gas, and aqueous. So we're going to keep that in mind as well. So your objective is to understand how to write this expression, this equilibrium expression K, for heterogeneous reactions. Pause the video, fill in that one spot, and then play to hear my words. Homogeneous, of course, remember, means that the reactants and products are going to be in the same phase. They're all going to be gases. They're all going to be liquids. They're all going to be aqueous, right? But in heterogeneous means that the reactants and products are in more than one phase. So it could be a solid to a liquid. It could be a solid to aqueous. So let's think about different things that this could be. So you already know, and that's what I should have rung a bell, like, oh, if there's hetero and homo and what's going on here and the different states of matter, we want to remember that only gases are actually written in that equilibrium expressions, right? Solids and liquids are out. Why? Because their concentrations do not change. So think about this. Solids and liquids are going to always have a constant value. So if we take a chunk of solid and we actually double its mass, that means its volume is also going to double. So that ratio between that mass and the volume stays the same. So because it's a constant volume, constant value, since it's a constant value for solids and liquids, they are not part of that equilibrium expressions. We know, however, gases can change their volume depending on pressure. So that's why they are part of the equilibrium expression, as well as aqueous. Let's go back to that aqueous, and the reason for that is we've already talked about strong and weak acids and bases, and we already talked about this equilibrium arrow for something like a weak acid. So if we look at this particular reaction, everything is aqueous, and that's still going to be part of the equilibrium expression. So gases and aqueuses are always going to be part of that constant, that equilibrium constant, but solids and liquids are out of the reaction, or out of that expression. So here's an example. Again, H2 gas plus I2 solid would yield to HI gas. So what would be the equilibrium expression? Well, again, products over reactants, always to the exponent of the coefficients. So the HI would be included because it's gas, and the H2 would be included because it's gas, but the solid would be left out because it's a solid. It does not change. So pause, give it some thought, and see if you can come up with an answer. First, you need the actual equation. If you did not have this equation, you're not going to know that the K for the pressure is going to be the pressure of that H2O gas. So the H2O liquid is not part of it. Now, if you had it the other way for whatever reason, if you had the H2O gas going to the H2O liquid, then it would be 1 over the H2O gas, and that would not be right because we're talking about the evaporation. Again, give it some thought. See if you can come up with the correct equilibrium expression for this. And you should have gotten that. Again, water is not going to be part of that expression because it is a liquid. But everything else, all of those AQs would be. And this is going to be really, really, really important in our acids and base chapter coming up soon. So instead of a KC, it's actually going to be a KA or a KB for weak bases. And you might have noticed that in the slide where I showed you that HF expression, that HF equation. So Quicky Quiz. So pause, see if you can come up with the A, B, or C answer. Hopefully you came up with that. And if you did not, if you're still not understanding how to write an equilibrium expression and what goes in and what does not, or what is not part of the expression, please touch base with me in class. See you then.